this automatically becomes 0. So what are we now saying? What we are saying here now is we can write this one as summation k equals to even to infinity of minus of 1 sub k divided by k plus 1 k factorial into multiply by 2x k plus 1. That is what we are going to have. Having done that, the next line of action is for this is no longer the counter here is no longer in the order. This is purely even. The odd number are no longer here. So what do we do to ensure that our counter follow the counting pattern? That is 0, 1, 2, 3. This one is 0, 2, 4, 6. So we want to return it to 0, 2, 1, 3 and 0, 1, 2, 3. How do we ensure that? We know that the general term for even number is 2k. So we ensure that every point we see k, we substitute 2k. Every point we see k, we change it to 2k. So that this one becomes 2k plus 1. This becomes 2k plus 1. This becomes k plus 2. This becomes 2k. This becomes 2k factorial. So we have that summation. Let me erase it here. Rub off all this. So we have lane 1 plus x divided by 1 minus x becoming summation k from 0 to infinity. I have 1 sub 2k. I have 2x raised to the power 2k plus 1 divided by 2k plus 1 2k factorial, which can be 2x summation k from 0 to infinity. Of course, we have established the value of this one before. Let me write 1, 2k. I have this one to be x raised to the power 2, then k outside, divided by 3 divided by 2. I have sub k, then I have 2k factorial. Now it can be established. We can establish the fact that 2k divided by 2k factorial is the same thing as 1 sub k divided by k factorial. That can actually be established. In that light, we write lane 1 plus x divided by 1 minus x as 2x summation 1 sub k half sub k divided by 3 over 2 sub k factorial x is power 2 then k from 0 to infinity, and the final result becomes 2x f1 semicolon half semicolon 3 over 2 comma then semicolon x squared, and that is the factorial, sorry, that is the hypergeometric representation of lane 1 plus x divided by 1 minus x. Now, it is possible that we attempt this question in another form. The other form of attempting this question is to first write, since we have expanded it as ln 1 plus x minus ln 1 minus x, we represent this one in terms of factorial function, we represent this one in terms of a hypergeometric function, we also represent this one in terms of hypergeometric function. Then we subtract the two of them, and that subtraction depends on how much we can undo the factorization of hypergeometric function, which will be the focus of our next class. How do you factorize this? That is, we will take one or two questions in our next class to actually illustrate this. Finally, today, let us quickly look at how do we differentiate hypergeometric function. How do we differentiate? I will take this as example, derivative of hypergeometric function. Example 2. Suppose f alpha beta semicolon gamma semicolon k semicolon x is hypergeometric function, comma, obtain the derivative of f, full stop. Solution. How do you obtain the derivative of f? We are going to start from the first principle. We start from the definition. By definition, we know that f alpha beta semicolon gamma semicolon x is the same thing as summation k from 0 to infinity alpha sub k beta sub k divided by gamma sub k factorial x raised to power k. That's what we have. The variable here is x, while others are parameter. Alpha, beta, gamma are parameters of the hypergeometric function. How do we now carry out our differentiation? Our major focus will be on x. Let us obtain the derivative. ddx of f alpha beta semicolon gamma is differentiate x raised to power k. We obtain alpha sub k beta sub k divided by gamma sub k factorial k from 0 to infinity x raised to power k x raised to power k minus 1 divided by k x raised to power k minus 1. That is what we have as our differentiation. What next? Observe that k, we cancel out k factorial here. The first term of the expansion of k factorial will cancel. And that gives us gamma sub alpha sub k beta sub k factorial function of gamma k minus 1 factorial x raised to power k minus 1. Now, our counter. What will be the effect of that simplification on our counter? Let's look at it. If we should make this counter to start from 0, we are going to generate a negative factorial here, and we need to avoid that. In order to avoid that, we move the counter to 1 to infinity. However, this is against the definition of hypergeometric. The definition of hypergeometric states that the counter must always start from 0. If that is the case, then what do? We return this counter back to 0. And in order to make this spot 0, then we need to transform this. So, if we are to transform this, we transform this to k plus 1. So that by the time we subtract 1 from both sides, we naturally have our k to become 0. And what is the implication of that on the other terms that we have here? The implication of that is that for every point that k's appear, for every point that k appears, we substitute k plus 1. For every point that k appears, we substitute k plus 1, so that we have summation alpha k plus 1 beta k plus 1 divided by gamma k plus 1 k factorial that is need to be preserved from 0 to infinity, and this becomes s raised to power k. Now, this is what we have. Then what is the next line of action? We need to return this one back to k in order to define the factorial function from the definition point of view. Similar thing will happen here and here. Let me take just one of the parameters, say alpha. I have alpha k plus 1. By definition, this is alpha, alpha plus 1, alpha plus 2. It continues until I have alpha plus k plus 1 minus 1, which eventually gives us alpha, alpha plus 1, up to alpha plus k minus 1, and then alpha plus k. Now observe that if you take this one from here to here, it defines alpha sub k. We are going to have this one, and the presence of this one will have issue with this. In that case, we move to the second term. From this point to this point defines a factorial function. And what is that factorial function? That is alpha plus 1 sub k. So that means that alpha sub k plus 1 can be written as alpha plus 1 sub k. In that case, what should we do? So that means that our dx of f alpha beta gamma x can now be written as summation, cannot be written as alpha beta divided by gamma, alpha plus 1 sub k, beta plus 1 sub k divided by gamma plus 1 sub k, k factorial x is to the power k, k from 0 to infinity, and that gives alpha beta divided by gamma, f of alpha plus 1 beta plus 1 semicolon gamma plus 1 semicolon x, and that gives the differentiation of hypergeometric function. So far in today's class, we have discussed hypergeometric function. We discussed how some functions can be converted to hypergeometric function. We look at various examples. We also look at the differentiation of hypergeometric function as can be seen on the board. Our next class we look at more examples, particularly on how to factorize hypergeometric function and also the integral representation of hypergeometric function. Till the next time that we meet, my name is Abdulgani Ridwanullah Iyoda. Thank you. We'll meet next time.